World War II was not fought only with steel and explosives, it was fought with wood. Barracks, bridges, ammunition crates, observation posts, trench supports, skis, sleds, aircraft components, and vehicle decking all relied on timber. Much of it was used in environments that were relentlessly wet, frozen, muddy, and hostile to organic materials. From the forests of the Ardennes to the swamps of the Eastern Front and the rain-soaked Pacific, armies learned very quickly what worked and what failed. There was no patience for theory. If wood rotted, warped, or collapsed, men died and operations failed. What emerged from this pressure was a brutally practical field logic for preserving wood under the worst possible conditions. That logic still holds up today. Why wartime wood protection focused on function rather than perfection? World War II engineers and field units did not aim to preserve wood forever. They aimed to keep it functional long enough to matter. This distinction shaped every decision. Wood was not expected to look good or remain dry at all times. It was expected to resist catastrophic failure. The first rule was acceptance. Wetness was unavoidable. Instead of trying to seal wood completely, which often trapped moisture inside, the focus was on drainage, airflow, and rapid drying between exposures. This mindset alone prevented many failures. If you apply this today in cold or wet environments, stop trying to make wood waterproof. Focus on helping it dry. How elevation and separation from ground moisture became non-negotiable. Field manuals and combat engineering reports repeatedly emphasized keeping wood off the ground. Soil contact was the fastest way to invite rot and freeze damage. Wooden floors in barracks were raised. Crates were stacked on dunnage. Bridges used stone, steel, or sacrificial sleepers between soil and load-bearing timbers. Even temporary structures followed this logic. A few inches of elevation dramatically extended service life. You can apply this immediately by ensuring no structural wood rests directly on soil or concrete without a barrier. Simple spacers, stones, or treated sleepers make a significant difference. So, why did constant airflow matter more than just applying protective coatings? In those cold and wet theaters, stagnant moisture was actually deadlier than exposure itself. World War II engineers, they designed structures with gaps, vents, and spacing that allowed air to move freely. This approach, it prevented moisture from freezing inside the wood, which is what causes internal cracking and fiber rupture. For modern use, leaving ventilation gaps in sheds, cabins, or storage structures often preserves wood better than sealing everything up tight. In a lot of situations, proper preservatives just weren't available. Field units had to make do with whatever they had on hand. Oils, greases, even diesel fuel, used motor oil, and animal fats were all pressed into service, applied to exposed wood surfaces as improvised treatments. While these solutions might have seemed crude, they actually worked by displacing water and slowing down how much the wood absorbed. This really wasn't just random behavior. Soldiers noticed that oiled wood shed water and resisted freezing damage much better than untreated wood, which was a real advantage out there. A controlled modern equivalent would be applying penetrating oils or wax-based treatments to vulnerable areas like end grain, joints, and contact points. Why end grain received special attention? World War II field logic recognized end grain as the weakest point. Water enters wood fastest through exposed ends. Engineers sealed end grain with tar, pitch, oil-soaked cloth, or layered coverings. Crates often failed from the ends inward, so reinforcement focused there. In cold conditions, frozen end grain split beams and boards rapidly. You can actually apply this today by sealing end grain aggressively and, designing structures so that end grain is protected from direct exposure. How modular replacement reduced the need for perfect preservation. Instead of, over-engineering every single piece, World War II structures were designed so that parts could be replaced easily. Bridge planks, decking boards, and supports were standardized. When one piece failed, it was swapped without dismantling the entire structure. This reduced the need for long-term preservation and increased operational resilience. For survivalists or builders today, designing structures with replaceable components can extend overall lifespan even when individual parts fail. One critical insight from cold fronts was that wood must be allowed to move. Why freezing cycles were managed through movement allowance. Freezing and thawing causes expansion and contraction. Rigid fastening causes splits and joint failure. Structures were built with slotted holes, flexible joints, and minimal over-tightening. Nails and bolts were used to hold position, not to lock wood in place. Applying this logic today means avoiding rigid assemblies in climates with freeze-thaw cycles. Allow movement and the structure will survive longer. How usage itself became a preservation method. In many cases, regularly used wooden structures lasted longer than abandoned ones. Movement, vibration, and periodic drying from use prevented moisture from settling permanently. This is why active bridges, walkways, and platforms often outlasted unused ones in the field. The lesson is simple. Wood deteriorates fastest when neglected. Regular inspection and use reveal problems early. What World War II field logic teaches us about real-world durability is, pretty fascinating. The preservation of wood during World War II was not elegant. But, it was effective. The principles were simple. Keep wood elevated, encourage drying, protect end grain, accept exposure, allow movement, maintain regularly. These principles emerged under extreme pressure, where failure had immediate consequences. That makes them especially valuable today. If you value history that reveals how real people solved real problems under real conditions, subscribe to Relic Logic. Share this with anyone who believes practical knowledge still matters. The past does not whisper. It leaves instructions for those willing to pay attention.